Hello everyone. Today we're going to look at how to solve quadratic equations by using the quadratic formula. Now we have noticed that there are many possible ways to solving a quadratic equation, either by graphing or factoring. But when you can't or when you feel like you are having difficulty solving a quadratic equation by either graphing or factoring, you can always use the quadratic formula. The quadratic formula will always work. Now, in order to use the quadratic formula, your equation must be written in this format: ax squared plus bx plus c. And when you use the quadratic formula, it will give you at most two zeros. Now, remember that a zero is defined to be the x-intercept or the root of the quadratic equation. And this is the quadratic formula. X is going to equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. In order to apply the quadratic formula, the quadratic equation must first be equal to 0. So if your quadratic equation is written in some other format, make sure that you rewrite it so that it equals to 0 and in standard form. As a reminder, a represents the coefficient that is attached to x squared, b is the coefficient that is attached to the x, and c represents the constant, which is the number that does not have a variable attached to it. So now let's practice. Here we have x squared plus 8x plus 5 is equal to 2x. So now before I can even use the quadratic formula, I would have to make this equation equal to 0. And the easiest way to do that would be to subtract this 2x. And like this, I have the equation x squared plus 6x plus 5 is equal to 0. And in this case, a is equal to 1, b is equal to 6, and c is equal to 5. And now I am ready to start plugging it into my quadratic formula. Since we don't have the quadratic formula written out in front, I'm just going to write it up here, which is negative b plus or minus square root b squared minus 4ac all over 2a. So now we're going to plug these numbers into this formula. So x is going to equal to negative b, so negative 6 plus or minus the square root of 6 squared, which is 36, minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. And now we just work this out. So here we have negative 6 plus or minus the square root of 36 minus 4 times 1 times 5, which is 20, all over 2. If I continue, I get x is equal to negative 6 plus or minus the square root 36 minus 20 is 16, all over 2. Now the square root of 16 is 4, so we get negative 6 plus or minus 4 all divided by 2. Remember that I said that the quadratic formula would give you at most 2 answers, and this is an example of where we would have 2 answers, and that's because of the plus or minus. So in order to get both answers, we would do negative 6 plus 4 first, which is negative 2, and then we divide it by 2. To get the second answer, we would do negative 6 minus 4, which is negative 10, and then we divide it by 2. So my 2 answers would be negative 2 divided by 2, which is negative 1, and negative 10 divided by 2, which is negative 5. Let's look at this next example. Here we have 2x squared minus x is equal to 4. So again, first I would have to make this equal to 0, so I would subtract the 4, and I would get 2x squared minus x minus 4 is equal to 0. In this particular case, a is equal to 2, b is equal to negative 1, and c is equal to negative 4. And now I'm ready to plug everything into my quadratic formula. So x would equal to negative b. Since b is already negative, we make it positive, plus or minus the square root of b squared. Negative 1 squared is a positive 1, minus 4 times a, which is 2, times c, which is negative 4, and everything is over 2 times a, which is 2. Now let's work this out a little bit. So we have 1 plus or minus the square root of 1. Then here we have negative 4 times 2 is negative 8. And negative 8 times negative 4 will give me a positive 32. And everything is over 4. Now in this particular example, when we're working this out even more, we get x is equal to 1 plus or minus the square root of 33, all divided by 4. Now this is my answer. I don't know the square root of 33, and I can't simplify that square root because the only two numbers that multiply to give you 33 are 3 and 11, which are not pairs. So this is my answer, and you can separate this fraction to be 1 over 4 plus or minus the square root of 33 over 4. So all I did here was I separated my fraction so you have the exact answer. So like I said, 1 over 4 plus the square root of 33 over 4 and 1 over 4 minus the square root of 33 over 4. So these technically represent two solutions. Let's look at this next one here. We have x squared plus 9x minus 3 is equal to 3x minus 12. So again, first we make this equal to 0. So I would subtract the 3x and add the 12. And we get x squared plus 6x plus 9 is equal to 0. And in this case, a is equal to 1, b is equal to 6, and c is equal to 9. And now we're ready to plug everything into my quadratic formula. So negative b, which is negative 6, plus or minus square root of b squared, so 36, minus 4 times a times c, which is 9, all over 2 times 1. We work this out, we get negative 6 plus or minus the square root of 36 minus 4 times 1 times 9 is 36, all over 2. Now, this is an example when I don't get two solutions and I only get one, and this is why. We end up with negative 6 plus or minus the square root of 0, and the square root of 0 is just 0, all over 2. If you end up with plus or minus 0, negative 6 plus 0 is still negative 6, and negative 6 minus 0 is still negative 6. So we're not adding or subtracting anything. So this would just be negative 6 divided by 2, which would equal to negative 3. And this would be my solution. In this last example, we have 7x squared plus 2x plus 3 is equal to negative 1. So first, I would add the 1 to make my equation equal to 0. And I get 7x squared plus 2x plus 4 is equal to 0. And in this case, a is equal to 7, b is equal to 2, and c is equal to 4. Now we're ready to plug it into my quadratic formula. So negative b, which is negative 2, plus or minus square root of b squared, so 2 squared, which is 4, minus 4 times a, which is 7, times c, which is 4, all over 2 times 7. Now when we work this one out, we get here negative 2 plus or minus the square root of 4 minus 4 times 7, which is 28, times another 4 is, let me think about that a second, which is 112. And it's all over 14. Now here what happens is, that when you subtract 4 minus 112, we get negative 2 plus or minus the square root of negative 108 all over 14. Now remember, when we have a negative inside of the square root, that means that we're going to make it positive and bring out the I, because this is going to be an imaginary answer. And even though it's not a real solution, because obviously it's imaginary, we're still going to simplify this radical and work it out. So I'm going to do the radical on the side and in a different color so we don't get confused. When we try to simplify the square root of 108, 108 is when you multiply 36 and 3. And 36 is 6 and 6. So here's my pair, and this is the number that would have to stay inside. So now let's rewrite this answer. We get negative 2 plus or minus. The 6 is on the outside, so 6, and then don't forget the I, square root of 3, and everything is over 14. Now we're going to simplify this even further, and to do so, just to make some space, I'm going to erase some of the work in the previous number here. So now what we're going to do is we're going to simplify this answer. In order to best simplify, what we can do is split up this fraction just like we did in the previous example. We have negative 2 over 14 plus or minus 6i square root of 3 also over 14. And now we can simplify these fractions. Negative 2 over 14 can be simplified by 2. So this would be a 1 and this would be 7, giving me negative 1 over 7 plus or minus. And then 6 over 14 can also be simplified by 2. 6 divided by 2 is 3. 14 divided by 2 is 7. And we end up with 3i square root of 3 over 7. And this would be my final answer. And these are my two imaginary solutions, negative 1 over 7 plus 3i square root of 3 over 7, and negative 1 over 7 minus 3i square root of 3 over 7. Now that we have a better idea of using the quadratic formula, we're going to focus a little bit on what's called the discriminant. The discriminant is the part that is inside of the radical in the quadratic formula, which is the b squared minus 4ac. Now the discriminant tells you how many real number solutions are going to exist when we find the answer. So just like here, how I told you, we can have at most 2 solutions. We have this example where we ended up with 2 solutions. We have in C where we ended up with only 1 solution. And then we had D where we ended up with 2 imaginary solutions, meaning no real solution. And that is based on the discriminant on the inside of that radical. So if the discriminant b squared minus 4ac is greater than 0, meaning positive, that means that we have 2 real solutions. And an example, a visual example of that is that your parabola is touching the x-axis in exactly 2 places, which is why we end up with 2 solutions. Remember that the quadratic formula gives you how many x-intercepts, or gives you the x-intercepts of that quadratic equation. Now, if the discriminant is equal to 0, that means that we only have 1 real solution. And that's because that means the parabola must have touched the x-axis in exactly 1 spot. And that is exactly what happened in this previous example, where we saw that inside of the radical we ended up with 0. And that's why we only had 1 solution. Now, if b squared minus 4ac is less than 0, meaning negative, that means that there are no real solutions, and that would be because the parabola here does not touch the x-axis at all. And so while we have no real solutions, that means that we have 2 imaginary solutions. So now let's have a closer look at the discriminant. Here we have two examples, and we're going to determine how many solutions this quadratic equation will have. And so the discriminant is used to describe solutions, meaning I'm not exactly looking for the answer or for the solution. I'm trying to tell you how many solutions I will end up having. So the discriminant, as a reminder, I'm going to write it up here, is b squared minus 4ac. So in this example, a is equal to 1, b is equal to -2, and c is equal to 3. And I'm going to go ahead and plug it into the discriminant. So b squared, -2 squared, minus 4 times a times c. Now -2 squared is a positive 4, and then -4 times 1 times 3 is -12. 4 minus 12 is equal to -8. Since the discriminant is negative, that means that there are no real solutions. Or you can also say that there are two imaginary solutions. Let's try that again. Here we have 2x squared plus 4x plus 2. In this example, a is equal to 2, b is equal to 4, and c is also equal to 2. And now I'm going to plug it into my discriminant. So b squared minus 4 times a times c. 4 squared is 16. Minus 4 times 2 is 8, times 2 is also 16. And 16 minus 16 is 0. So if the discriminant is 0, there is only one real solution. Now, why is this helpful? Let's look at some applications of the discriminant. In this first example, it says a ball is thrown in the air. The ball's height, h in meters at time t in seconds, can be modeled by the quadratic function h of t is equal to -4.9 t squared plus 14t plus 2. Does the ball reach a height of 12 meters? And if so, find the time when the ball will reach its maximum height. So, first we want to figure out if h of t will equal to 12. So that means that my equation here, -4.9t squared plus 14t plus 2 will equal to 12. That's what we want to figure out. Is this true? And in order to do so, right, this is just another quadratic equation. If I make it equal to 0, just like I do with all my quadratics, we end up with -4.9t squared plus 14t minus 10 equals to 0. Like this, what I can do is use the discriminant. So in this particular case, a is equal to -4.9, b is equal to 14, and c is equal to -10. So I'm going to plug it into my discriminant, that b squared minus 4ac. So that would mean we have 14 squared minus 4 times -4.9 times -10. When I work this out, 14 squared is 196. Then we have -4 times -4.9 times -10. When you multiply this all together, you would get a -196. Now, 196 minus 196 is 0. Since my discriminant is equal to 0, that means that I will have one solution. So the answer to this question, does the ball reach a height of 12 meters? Yes, because the discriminant tells me that there is one solution. Now we're going to find the time when the ball will reach its maximum height. So this is the quadratic equation. I've already set it up, and now we are solving for t. So now we can use the quadratic formula. So that would mean that -b, so -14, plus or minus the square root. Now we already solved for the discriminant. I don't need to go through this process again. The discriminant is equal to 0. And we put it over 2 times a, which is negative 4.9. Now remember that this gives me one solution. So if I add or subtract 0, it doesn't matter. So this is simply negative 14 divided by 2 times negative 4.9, which is negative 9.8. And when you divide negative 14 by negative 9.8, we get 1.43. This is my time, and the time is in seconds. So we would say that the ball will reach its maximum height at 1.43 seconds. In this next example, we have a person is creating a garden whose area can be modeled by the function a of w is equal to w times 50 minus w, where w is the width in feet of the garden. Can the garden have an area of 700 feet squared? And if so, find the width of the garden. So we are trying to figure out if a of w is going to end up equaling to 700. So I'm going to substitute my a of w with my equation, which is w times 50 minus w equals to 700. Now this is not exactly a quadratic equation. However, if I multiply this w, I get 50w minus w squared equals to 700. This is now a quadratic, and I'm going to want to write this in standard form, meaning that we want the term with the highest exponent in the front. So I'm going to rewrite this as negative w squared plus 50w is equal to 700. And just like with all of our previous examples, we want to make this equal to 0. And so this would give me the final quadratic equation of negative w squared plus 50w minus 700 is equal to 0. And now the whole point of using the discriminant is just to figure out if there is even a solution. Because if there is not a solution, then there's no point of working out the whole quadratic formula, which is why we're doing this. So can the garden have an area of 700 feet? We're going to use the discriminant now to find out. So in this case, a is equal to negative 1, b is equal to 50, and c is equal to negative 700. So now I plug it into my discriminant, which is b squared minus 4ac. So 50 squared minus 4 times a, which is negative 1, times c, which is negative 700. 50 squared is 2,500. Negative 4 times negative 1 is a positive 4, times negative 700 is a negative 2,800. And I get here 2,500 minus 2,800, which gives me negative 300. Because I end up with a negative discriminant, that means that no, this garden cannot have an area of 700 square feet. So we don't even have to bother with the second part of the question, because the garden will not have an area of 700 square feet. And that's using the quadratic formula and the discriminant.